A larger context window sounds like a simple solution to a very practical problem. Instead of deciding which pages matter, just give the model the entire PDF. Instead of building retrieval, just paste the whole thing in the prompt itself. Instead of filtering the logs, just send everything to the model. After all, if the answer is somewhere inside the context, the model should find it, right? But that assumption is not entirely correct. When you do that, the model is no longer just answering a question. It is searching, filtering, ranking, resolving conflicts, and deciding which details deserve attention. And that is why a million token context window can still miss a sentence that was technically right there. In this video, we'll break this into three parts. First, what a context window actually is. Second, why putting more tokens into that window does not automatically mean the model understands the document better. And third, what this means in real systems, where clean retrieval, chunking, re-ranking, and prompting often matter more than simply giving the model everything at once. Welcome to Scovia, where we make AI concepts feel like everyday ideas. A context window is the amount of text a large language model can consider at one time. You can think of it as the model's working memory. It's essentially the size of your prompt, and it is measured as the number of tokens. When we say a model has a context window of 128,000 tokens or 1 million tokens, we mean the prompt and any other additional system information, such as the documents, conversation history, etc., have to fit inside that space. A token is usually a piece of a word, which could be the full word or the punctuation, etc. So a longer context window lets the model accept more material. Here is a table showing the typical context window size of current models. The context window determines what information the model can access at the moment it makes a prediction. This is different from the knowledge the model already has from training. Training gives the model its general patterns, facts, and abilities. The context window gives it the specific information available right now: the user's question, the conversation history, and any documents or examples placed inside the prompt. So, when we use an LLM to answer a question from a document, context size matters. If the document is 100 pages long and the model only supports a small context window, we cannot simply paste the whole thing into the prompt. That was one reason larger context windows became so useful. It is tempting to think about the context like storage. If the window is bigger, we can put more information inside it. And if we put more information inside it, the model should become more informed. But LLMs do not read long prompts the way a human reads a carefully organized report. Fitting the information into the prompt is not the same as getting the model to use it well. They process a long sequence of tokens, then generate the next token based on patterns learned during training and signals from the current prompt. So, more input gives the model more material, but it also gives the model more noise, more irrelevant details, more repeated phrasing, and more near matches. More information that looks important but is not actually relevant. And once that happens, the task has changed. The model is no longer just answering a question, it is searching through the context, weighing competing signals and deciding which parts deserve attention. That is why more tokens can help, but they can also make the answer harder to find. We'll go over the reasons a model can fail even when the answer is inside the context. The first is attention dilution. When the prompt is short and focused, the relevant information is easier to emphasize. But when the prompt becomes very long, the important sentence may be one small signal among thousands of weaker signals. The model can still access it, but the access is not the same as priority. The second issue is often called lost in the middle behavior. In theory, self attention lets tokens interact across the whole context window. So the answer is not far away in a simple distance sense, but access is not the same as influence. In practice, models can sometimes use information more reliably when it appears near the beginning or the end of a long context. And this paper that you see right here proves that. Information buried in the middle may have less effect on the final answer, especially when it is surrounded by many similar or irrelevant passages. This is what makes this failure very subtle. The paragraph was inside the prompt, the model could attend to it, but it did not weigh it strongly enough when producing the answer. The third issue is irrelevant context. If you include five documents and only one matters, the other four are not neutral. They can pull the model towards the wrong interpretation. This becomes especially common in enterprise settings. A legal team may include an entire contract, a support team may include all historical tickets, or a data team may include complete logs. The hope is that more context gives the model everything it needs, but sometimes it gives the model too many plausible paths, and only one of them is correct. The fourth issue is conflicting information. Long documents often contain old rules, exceptions, duplicated sections, some draft language, or some outdated policies. A model may find a statement that looks relevant but is no longer valid, or it may blend two sections together. For example, if one paragraph says customers can cancel at any time, and there's another paragraph that says enterprise customers require a 30-day notice, and maybe another one for regional contracts, which may override the standard policy. The correct answer depends on which rule applies. More context does not solve that automatically. It may make the conflict harder to resolve. The fifth issue is weak prompting. Long context needs clear instructions. If the model is not told what to look for, what to prioritize, or how to handle conflicts, or what to do when evidence is missing, it may default to a broad summary. And broad summaries are often not what enterprise users need. They need the precise clause, the latest rule, or the reason one source overrides another, and things like that. So, what do we do about helping the model arrive at the desirable answer? Let's look at some alternatives that don't rely on the context size. They break down these tasks into separate steps. First, retrieve the most relevant chunks, then re rank them, and then summarize or compress them if needed. Then give the model a smaller, cleaner context. You do this not because the model cannot handle more tokens, but because the model answers better when the evidence is organized. This is the core idea behind retrieval augmented generation. The retrieval system narrows the search space. Chunking breaks documents into meaningful units. Re-ranking improves the order and relevance of those units. Summarization removes repeated or low value information. Now, the LLM is not being asked to search an entire warehouse. It's being handed the right files, the right labels in the right order, and that changes the quality of the answer. Consider a bank using an LLM to answer internal compliance questions. One approach is to place the full compliance manual, all policy updates, and all regional exceptions into the context. The relevant rule might be inside, but so are old policies, edge cases, overlapping definitions, and exceptions for different products. A better approach is to retrieve the relevant policy sections for the exact product, the region, the customer type, and the date. And then the model answers from a smaller set of evidence. The context window is still useful, but it's being used carefully. So the idea here is that long context is powerful, but clean context is often more powerful. This does not mean large context windows are useless. They're extremely useful when the information is well structured. For example, reviewing a long transcript where the timeline matters, comparing sections across a long report, or understanding a code base when the files are clearly organized, or analyzing a contract where the clauses are labeled and the question is specific. Or maybe working with a long document where the relevant information is clearly signaled. In these cases, a bigger context window gives the model room to connect ideas across distance. That can be valuable, but the benefit depends on structure. A long context works best when the model can tell what each section is, why it matters, and how it relates to the question. A bad long prompt might say something like, "Here are 700 pages. Answer my question." A better prompt will say something like, "Use the active policy sections below. Prioritize the most recent rule. If there's a conflict, explain which source governs. Cite the exact section used." The second prompt gives the model a decision process, and that often matters more than raw context length. To summarize, a large context window does not automatically mean a better answer. It means the model can accept much more information at once as a part of the prompt. And that is useful. But a better answer still requires better context design. The relevant information needs to be selected carefully, structured clearly, and given in a form that the model can actually use. That can happen inside a long context window or with systems like retrieval augmented generation. A large context window gives the model more room, but good context engineering gives it a better chance of using that room correctly. If you found this content useful, please subscribe to Scovia, and as always, stay curious.